Thank you for following yet another episode of At Mr. Marino Science. Today's episode is a little bit different. This is kind of serving as a review for the periodic table of elements, how to read an element key, and how to draw an atom in a dot diagram. We're going to start right off with drawing the element key, giant rectangle. You'll find a bunch of these in the periodic table of elements. I wrote XY as an example. XY will represent the atomic symbol. So when you look at the periodic table of elements, you'll see that there are many letters that represent the many elements in the table. In the upper left-hand corner, and sometimes straight up above the atomic symbol, you'll find the atomic number. There are three things that you should know about the atomic number. Thing number one, it's the identity of the element, and it'll never change. Two elements won't have the same atomic number. Thing number two is the atomic number tells you how many protons there are in the nucleus of one atom of that element. So that's very useful information, which we'll use later on. And number three, it's always a whole number, never a decimal. Now down below, we have a number that is a decimal. That number is the atomic mass. And most of the time, it is a decimal. The atomic mass is located under the atomic symbol. Now, the atomic mass is the mass of the entire nucleus, which contains protons and neutrons. And we'll say that a few more times throughout this vlog. So now let's do a real-life example here. In this example, I wrote the atomic symbol Li, which stands for the element lithium. Lithium's atomic number is 3, which means lithium has 3 protons in its nucleus. I wrote its atomic mass, which is 6.941. So right over here I drew the nucleus, and I let plus signs represent the 3 protons in the nucleus. I also drew 3 neutrons. Now the electrons, since there are 3 electrons, it's a 3-3-3 type of thing, I put 2 on the first ring and then the third one on the next ring. And there's a reason why I did that and not just all 3 on one ring. So you see the electrons, they orbit the nucleus, but they do it in a certain way. 2, 8, 18 is the order of the electrons that are allowed in each ring. As you can see in the upper right hand corner, I wrote 2, 8, 18, and usually have that there available for my students so they know how to distribute the electrons. Now let's take a note for a second here and write about our subatomic particles. We have our protons, which I mentioned, which can be determined by looking at the atomic number. We have neutrons, which are also located in the nucleus of an atom. And then we have the electrons, which orbit the nucleus. Protons have a positive charge, and so I let that be represented by the plus sign. Neutrons have no charge, so I just put an equal sign there. And the electrons are negative. Another place that you might want to put a little side note is next to the protons and neutrons is that they're both located in the nucleus of an atom. Very important to remember that. So, let's do example 2. This time, we're going to do a dot diagram, which is another important thing to understand in chemistry, especially when it comes to atomic bonds. So, here our example is oxygen. We wrote the letter O, which is the atomic symbol, the atomic number, which is 8, and also tells us how many protons are in the nucleus. I drew my 8 plus signs, I drew my 8 letter N's, so now we can see that the atom's nucleus is complete. And I even labeled it. Now, since we have 8 protons, it means we have 8 electrons. So let's get to work on our electron clouds. The first cloud is going to have 2 electrons, because that's the maximum number that the first electron cloud will hold. The second cloud can hold a maximum of 8. But in our example, oxygen has 8 total electrons, which means we're going to put 2 on the first cloud and 6 on the second cloud, which gives us a total number of electrons of 8. Let's look this over one more time. 1, 2 on the first cloud, 1, 2, 3, 4, 5, 6 on the second cloud, 6 plus 2 is 8. There are 6 electrons on the outer shell. 1, 2, 3, 4, 5, 6. That's something worth noting because now that we're going to go to work on our dot diagram, it's important that we know how many electrons are located on the outermost ring. Now, since there isn't a third ring, we're not going to write 0, but we look here and we can see that there are 6 electrons on the outer ring. So what we're going to do is, to do a dot diagram, we look back at our element key and we find out what our atomic symbol is. In this example, it's the letter O, capital letter O. So we take our atomic symbol and we write it down. Next, we have to answer the question, how many electrons are on the outer shell? Well, as I said several times, there are 6. So we look and we go 1, 2, 3, 4, 5, 6 to confirm that on 6 electrons on our outer shell. And those 6 electrons are going to be drawn in as dots, hence the name dot diagram. Now, there's no right or wrong way to draw these dots around the atomic symbol for the dot diagram, but it's probably best practice to pair them off to make it easier to count. Because if it gets messy and you just start putting them all over the place, you could miscount and it could be wrong. Now, it's important to know how many electrons are on the outer shell because later on when it comes to bonds, that's something that matters. So, we have our combination here, 2, 8, 18. Let's do another one. We have helium. So we're going to draw what helium looks like. 2 protons, 2 neutrons. It's got an atomic number of 2. And we put our 2 electrons on the first cloud. Well, that's all we have. And so, I ask the important question again, how many electrons are on the outer cloud of helium? Since there's only one cloud, the answer is going to be 2. 2 electrons. So, the dot diagram, we're going to take the atomic symbol, which in this case for helium is He, and we're going to draw 2 little dots right next to each other. Boom. There you go. That's how you do a dot diagram. Dot diagram represents how many electrons are on the outer shell of an atom. Alright, let's come up with another example. In this example, we're going to use carbon, which has the atomic number of 6. This time we're going to talk about isotopes. Isotopes are when you have 2 or more atoms of the same element, and the only difference between them is the number of neutrons. Now in this example I drew carbon, which has 6 protons, 6 neutrons, and 6 electrons. Now generally speaking, when we have our atomic number, in this example 6, we're going to have 6 of each. 6 protons, 6 neutrons, 6 electrons. We all know where they go. Now, since the atomic number is 6, we know that that number will never change. It'll always be 6 for carbon. Carbon will never have a different number of protons. It's permanent. It's always 6. However, the number of electrons can change, and so can the number of neutrons. That does not change the identity of the atom. That atom will always be carbon because its atomic number is permanently fixed. It's the identity. So in this example, I'm drawing another carbon atom, but it's going to be a little bit different. In this example, there are 5 neutrons. So we have 6 protons in the nucleus, and we have 5 neutrons. That does not change the identity of the atom. The atom is always going to be that element. So as you can see, if you have 2 atoms of the same element, they can be slightly different. They're called isotopes. These are 2 isotopes of carbon. And so as a quick note, we're going to write down they're both atoms of carbon because they have 6 protons. Okay? Now we take a look at this. They both have 6 protons. It circles back to the atomic number, which is the identity, and that never changes. For an isotope to be an isotope, it's the number of neutrons. To identify an isotope, you have to look at the number of neutrons in each atom. Number of neutrons can be different within the same element's atom. And that's okay. Okay, the next thing we're going to look at is how to find out how many average neutrons an element has. And to do this, I got some examples on the board. We wrote their element keys, I wrote in their atomic mass, I wrote in their atomic number, I labeled atomic number at the top, and I labeled atomic mass at the bottom. The second piece of information that we need to look at here is the atomic mass. It's the total mass of an atom's nucleus. Well, what's inside of an atom's nucleus? Protons and neutrons. So when we look at the atomic mass number, that's the total mass of the protons and neutrons. So, to determine how many neutrons there are, we take the information that we know and we use it. I'm setting up my equation. You take the atomic number and you subtract it from the atomic mass. You take the atomic number and you subtract it from the mass. And so all I did was write on the element key. I drop the number below and I subtract the atomic number from the atomic mass and I get a number. That number is how many average neutrons. Same as over here. I take 10 and I subtract it. I take 13 and I subtract it from the mass. I took 18 and I subtract it from the mass. And now on the line below you can see the number of neutrons for each atom. You have to remember that the atomic mass minus the atomic number will equal the average number of neutrons. Remember this equation and use it. Alright, so let's practice here. We have 4 examples. We have nitrogen, neon, aluminum, and argon. We drew their element keys. We're going to practice doing some dot diagrams. So the first things first is we get to work on the nucleus. Put 7 protons and 7 neutrons. And then we put 2, 4, 5 electrons on the outer shell. So we let that be represented by 5 electrons. Next we have neon with an atomic number of 10, which means that there are 10 protons in the nucleus and 10 neutrons in the nucleus. So we got to draw our 10 electrons, and there we go. 2 on the first ring, 2, 4, 6, 8 on the second ring, which gives us a total of 10 electrons. But since the dot diagram is the electrons on the outer ring, we're only going to draw 8, because that's how many are on the outer ring. 2, 4, 6, 8. 8 dots. Now moving on to aluminum. Aluminum has an atomic number of 13. So we'll go to work and draw in our 13 protons and our 13 neutrons inside of the nucleus. And we'll continue drawing our first ring, which will only hold 2 electrons. Our second ring, which will hold 8 more, which gives us a total of 10. But wait, we have 3 more to draw, so we put that last ring and we put the 3 on the outside of the ring. Look in the left-hand corner of your screen. See where it says 2, 8, 18 on the other board? Let that be your guide. So we take aluminum and we see that there's 3 electrons in the outer shell. So we put the 3 dots around the atomic symbol Al. And last but certainly not least, we have argon, which has an atomic number of 18. So we put 18 protons and 18 neutrons inside of the nucleus. And we get to work on drawing our electron clouds. 2 on the first one, 8 on the second one, which leaves us with 8 more to put on the outer cloud. You're going to notice, with elements greater than 10, first 2 clouds are always going to be filled, because that's 2 and 8, so that's 10. So where argon has an atomic number of 18, we know that there's going to be 8 in the last shell. So it could be a quick way for you, if you're good at math, to skip drawing the atom and just get right to work on the dot diagram. That's that.